Hi, today's lesson is on word problems. We've seen word problems several times in earlier lessons. Let's focus on some more where we use all the algebraic techniques we've learned so far. Essentially, word problems are about translating English language phrases into their mathematical equivalents. So, let's see some typical examples of phrases that occur and the mathematical symbols that mean the same thing. 4 more than x. So if you see a phrase like 4 more than x, this means it's referring to a number that's 4 more than x. So I can denote it as x plus 4. This number x plus 4 is 4 more than x, obviously. 7 less than y. So here we need to denote the value 7 less than y. So I take away 7 from y and I get a value that's 7 less than y. So y minus 7 denotes 7 less than y. K less than 25. Here I need to denote a value that's k less than 25. So I take k away from 25. So I do 25 minus k. So 25 minus k denotes the value k less than 25. 3 times Ninad's age. So obviously I first need to give a variable to Ninad's age. So let Ninad's age be denoted by t. Then I need to denote 3 times Ninad's age. So I need to denote 3 times t, which is written as 3t. So 3 times Ninad's age then becomes 3t. Mikhail is 1/5 his mother's age. So I firstly need to denote Mikhail's mother's age. So mother's age can be denoted by m. So if his mother's age is m, Mikhail's age is 1/5 of that. So I multiply his mother's age by 1/5. So that's 1/5 times m. That is m by 5. I could equivalently just divide his mother's age by 5 to get 1/5. So Mikhail's age is m by 5. Hemant is 3 less than twice his sister's age. 3 less than twice. So there are many things happening here. But first we need the sister's age. So Hemant's sister's age can be denoted by x. Hemant's age is 3 less than twice his sister's age. So we need to first find out twice his sister's age. If her age is x, twice her age would be 2x. You still not got to Hemant's age because Hemant is 3 less than twice. So Hemant is 3 less than this. And to get 3 less than 2x, we subtract 3 from 2x. So Hemant's age will be 2x minus 3. That's twice x and then take away 3. If minus 2 is 8 more than x, then what is the value of 2x by 5? Okay, to find out the value of 2x by 5, I first need to find out the value of x. And I'm guessing this information will help me get the value of x. Minus 2 is 8 more than x. So minus 2 is means equal to. Minus 2 is equal to 8 more than x. That means it's x plus 8. Now I can solve for x. I subtract 8 from both sides. And I get minus 10 is equal to x. So I found x's value, it's minus 10. Check by using the sentence that described x. Minus 2 is 8 more than x. So if x is minus 10, 8 more than x would be minus 10 plus 8, which is minus 2. And yeah, minus 2 is 8 more than x. So minus 10 was the correct answer. Now it's easy. What is the value of 2x by 5? So that's 2 into minus 10 divided by 5. 5 goes into minus 10 minus 2 times, so I get minus 4. And the answer is B. So it all boiled down to understanding the sentence. Minus 2 is 8 more than x. The cost of a picture frame M is $10 less than 3 times the cost of picture frame N. Let the cost of picture frame M be denoted by M and the cost of picture frame N be denoted by N. So the cost of picture frame M is, so M is equal to 10 less than 3 times. 10 less than 3 times the cost of frame n. 3 times the cost of frame n would be 3n, and then we need 10 less than that, so minus 10. There are two operations here. 3 times the cost of the frame and then 10 less than 3 times the cost of the frame. So I get a 3n and then I get a 3n minus 10. And this expression is the cost of picture frame M. So it's equal to M. Then if the cost of frame M is 50, great. So if M is 50, we have our equation. What is the cost of frame N? That means what is N? Now it's easy enough to solve. 50 is equal to 3n minus 10. Add 10 to both sides. I get 60 is equal to 3n. Divide both sides by 3. I get 20 is equal to n. So the cost of frame n is $20. Answer is C. The cost of a portrait P is $15, more than twice the cost of frame F. Cost of portrait P is 15 more than twice. So let the cost of frame F be F. Twice the cost of frame F would be 2F. And it's 15 more. So I add 15 to make it 15 more than 2F. And that is the cost of portrait P. So P is equal to 2F plus 15. If the cost of portrait and frame is 90. Okay, so it's the cost of portrait plus frame. The sum of their costs is 90. They haven't directly given me one of the costs. They've told me the cost of the portrait and frame is 90. So I have two equations in P and F. What do I do? Well, I can find F from the second equation. So F will become 90 minus P. I subtract P from both sides. And I substitute this value of F into the first equation. Why do I do that? So that everything is in terms of P. And that's what I want. I want P. So substituting this value of F in the first equation, I get P is equal to 2 times 90 minus P plus 15. So P is equal to 2 times 90, that's 180, minus 2 times P, that's minus 2P plus 15. I can take the minus 2P on the other side, that is I add 2P on both sides, and I'll get 3P is equal to 180 plus 15 is equal to 195. So P will turn out to be 65. And the answer is E. So, interesting question here. I got two relations in P and F. Each sentence gave me one relation in P and F. So I could solve them simultaneously, as we call them. But rather than solving them simultaneously, I express F in terms of P, and then I use that expression for F in the first equation, and I get this equation, which is an equation now totally in P. So I can solve for P. Some of the most common questions that occur in all exams are questions involving consecutive integers. So what are consecutive integers? Integers of the form 2, 3, 4, 5, or minus 6, minus 5, minus 4, or 99, 100, etc. 98, 99, 100, and so on. So how would I express consecutive integers using algebra? So if one integer was x, the one after it would be x plus 1, and the one after that would be x plus 2, and the one after that would be x plus 3, and so on. Or if one integer were x, the one before it would be x minus 1, the one before it would be x minus 2, and the one before it would be x minus 3. So both these rows are sets of consecutive integers. I could of course mix and match, and I could say my middle integer is x, so the one before it is x minus 1, the one after it is x plus 1, and the one before that is x minus 2, and the one after this is x plus 2. So these 5 integers are also consecutive integers. My choice of where x is and whether I move left or right depends on the nature of the question. It's useful to use one or the other depending on the wording of the question. How about consecutive odd integers? What are odd integers? 1, 3, 5, 7, 9. The positive odd integers start at 1 and move in jumps of 2. Important. So x is an odd integer. What's the next odd integer? It's not x plus 1. It'll be x plus 2 because the odd integers occur in jumps of 2. So x plus 2 will be the next odd integer. X plus 4 would be the one after that. X plus 6 would be the one after that. Or if x is an odd integer, x minus 2 would be the one before that, x minus 4 would be the one before that, and x minus 6 would be the one before that. So as long as you have jumps of 2 and you specify that x is the first of the odd integers, each of them is obtained by adding or subtracting 2. Similarly, consecutive even integers, same game. Here x is an even integer. If x is an even integer, then of course x plus 2 will be the next even, x plus 4 will be the next after that, and so on. Or if x is an even integer, x minus 2 would be the previous even, and x minus 4 would be the one previous to that. Important that here x denotes an even integer to start with. Let's see some questions involving consecutive integers. Find the largest of 5 consecutive integers whose sum is 45. So I need 5 consecutive integers. So well, the easiest way to take 5 consecutive integers is x, x plus 1, x plus 2, x plus 3, x plus 4. These are 5 consecutive integers. The sum is 45. Fine, add them. So add these 5 integers. Let's put big pluses between them. And there are 5 x's, so I get 5x plus 1 plus 2 plus 3 plus 4. That's plus 10. So the sum of the 5 consecutive integers turns out to be 5x plus 10. And we are told the sum is 45. So I equate it to 45, solve for x, and I get x is 7. So is my answer 7 because x is 7? Usually x is the answer. No, it definitely isn't because they want the largest of 5 consecutive integers. And x was the least of my 5 consecutive integers. We started at x and we moved up. Which is the largest? Well, the largest is denoted by x plus 4. So that's 7 plus 4 equal to 11. So the answer is, the largest is 11, not 7. Be careful of what they ask. What they ask is not what you found out. Just because you found out x is 7 does not mean they're asking for x. Think of another nice way of selecting the 5 integers. Here's one. I'll take the middle integer to be x. So the one before it is x minus 1. The one before that is x minus 2. The one after that is x plus 1. The one after that is x plus 2. Why is this nice? Because when I add these 5 integers, the negatives 2, negative 1 and the 1 and 2 vanish. And the sum just turns out to be 5x. The sum turns out to be 5x. And remember, x is now the middle integer. So we get 5x is 45 and x turns out to be 9. How is that possible? Why not? Because the middle integer is 9. Remember in the previous question, we got the first integer to be 7. So the middle integer was 9. Here we got the middle integer to be 9. Again, they want the largest integer, which in this case is x plus 2. So x plus 2 will be 9 plus 2, which will be 11. And we have the same answer. So, whatever you're comfortable with, choose that as your 5 consecutive integers. Find the smallest of 4 consecutive even integers. So they want 4 consecutive even integers. So I'll take this first one to be x, the next one will be x plus 2, then x plus 4, and x plus 6. I'm adding 2 each time because they're consecutive even integers. They appear in jumps of 2. Remember, x here is an even number. If for some reason you work out x to be odd, then everything falls apart because we're assuming x is even. Let's add them. So that's 4 x's plus 2 plus 4 plus 6. That's plus 12. And that sum is equal to 44. That is given. So 4x will equal 32 and x will equal 8. Remember, x is not what they may be asking for. We've just found out x. Let's make sure we know what they're asking for. They're asking for the smallest and we have taken x as the smallest. So in this case, the answer is 8. If they were asking for the highest, then you'd have to add 6 to it. Lakshmi was 28 years old when her daughter Mahua was born. In how many years will Lakshmi be 2 years less than 3 times Mahua's age? Interesting. So what's the relationship between Mahua and Lakshmi? So when Mahua was 0 years old, Lakshmi was 28 years old. That's the relationship between the ages of Mahua and Lakshmi. So can I write an equation relating them? Yes, Lakshmi is 28 years older than Mahua. So no matter how old they are now, that gap is not going to change. They're still going to be 28 years apart because they were 28 years apart the day Mahua was born. So I can write that Lakshmi's age is Mahua's age plus 28. And this holds for all time as long as both are alive. So that's my first equation relating Lakshmi and Mahua. In how many years will Lakshmi be 2 years less than 3 times Mahua's age? So they are asking, in how many years will Lakshmi be 2 years less than 3 times Mahua's age? What will be 3 times Mahua's age? 3 times Mahua's age will be 3m. And what's 2 less than that? 3m minus 2. So I have an expression 2 less than 3 times Mahua's age. And they want Lakshmi to be that. So that's equal to L. Lakshmi should equal 3m minus 2. We know that Lakshmi is always equal to m plus 28. And we want this to happen. We want Lakshmi to equal 3m minus 2. So well, both are L equal to something, L equal to something. So I get rid of the L. I equate the two expressions in m. So I can take the m on the right side and the minus 2 to the left. And I'll get 28 plus 2 is equal to 3m minus m. That is 30 is equal to 2m, or 15 is equal to m. So it's telling me when Mahua is 15 years old, this is going to happen. So in how many years is that? 15 years, because Mahua was 0 to start with. So the answer is C. We found out how old Mahua is now, and that's 15 years from the day she was 0. So in 15 years, Lakshmi is going to be 2 years less than 3 times Mahua's age. There's something clever in this question. They haven't directly told you how old will Mahua be when Lakshmi is 3 times less to her age. They've actually told you how many years will pass. But how many years will pass since when? Since Mahua was born. So in effect, it is how old Mahua is. Sheila is twice as old as Tina, and Tina is 4 years younger than Uma today. So let's just put down this information. So let's say Tina is T years old, Sheila is S years old, and Uma is U years old. So Sheila is twice as old as Tina means Sheila is 2 times T. Sheila's age is twice Tina's age. And Tina is 4 years younger than Uma. If you add 4 to Tina's age, then you will get Uma's age. So T plus 4 will give me Uma. Uma is 4 more than Tina. If all 3 of them will still be alive 5 years hence, which of the following statements will be true on that day? Okay. 5 years hence. Let's see what happens 5 years hence. This is Tina, Sheila, Uma. So 5 years hence, Tina will be T plus 5, Sheila will be S plus 5, and Uma will be U plus 5. Each one will grow by 5. Sheila is twice as old as Tina. Well, is that true? We know that S is 2T, but S plus 5 is not going to be 2 times T plus 5, right? S plus 5 is not going to equal 2 times T plus 5 because the right hand side is equal to 2T plus 10. And since S is 2T, S plus 5 is going to equal 2T plus 5. It's not going to equal 2T plus 10. So this is not happening. Uma is 4 years older than Tina. Uma is 4 years older than Tina today. 5 years later, of course she's going to be 4 years older than Tina. Because both are going to grow by 5 years. Their gap is not going to change. Uma is going to become Uma plus 4. Tina is going to become Tina plus 4. So Tina plus 4 is equal to Uma plus 4. So the gap of 4 years will not change. So statement 2 is correct. Sheila is older than Uma. Well, these two statements really don't tell me anything about Sheila and Uma's age. Sheila is twice Tina and Uma is Tina plus 4. Can you determine who's older from these two? No. Let's see. If I take t equal to 1, then s is 2 into 1, which is 2. And u is 1 plus 4, which is 5. So when t is 1, Uma is older than Sheila. But say I take t as 5. Then s becomes 2 times 5, which is 10. And Uma becomes 5 plus 4, which is 9. So in this case, Sheila is older. So not knowing anything about Tina's age, I can't say anything about who's older between Sheila and Uma. So even 5 years later, I can't say who's older, because whoever is older now will be older 5 years later. That's not going to change. So only 2. 1 was out and 3 was out. Only 2. The answer is B. If the number n of calculators sold per week varies with the price P in dollars according to the equation n equal to 300 minus 20p. So what's n, what's p? N is the number of calculators and p is the price. And as the price p varies, the number n also varies. What would be the total weekly revenue from the sale of $10 calculators? So they've told you that the calculators sell for $10 each. So they've given you p. So since p is given, let's plug it in without further ado and get n. N is 300 minus 20p. P is given as 10, so I get 300 minus 20 into 10, which is 300 minus 200, which is 100. So what's this telling me? That when the price is $10, the number of calculators sold is 100. So I know for a price of $10, the number of calculators sold is 100. They want the revenue. Revenue, of course, is price into the number sold. So revenue is 100 sold at $10 each. That's 1,000. That's my revenue. Answer C. Which of the following equations represents the linear relationship between time t and velocity v shown in the table below? Okay, interesting. So what are they saying in this table? They're saying when the time t is 0, the velocity is 120. That's this ordered pair. When the time is 1, the velocity is 152. And when the time is 2, the velocity is 184. So we can write it as ordered pairs tv. So 0, 120, 1, 152, and 2, 184. These are the TV pairs. And you want to find that equation which works for all three of these values. I'm going to first use the value of t equal to 0 because that's very easy to manipulate. So v equal to 32t. If t is 0, v will also be 0. But here v is 120. So a is out. B is v equal to 32t plus 120. This works because when I put t equal to 0, I get v as 120. So B is a possibility. C, v equal to 120t. Not happening. When I put t equal to 0, I get v equal to 0. D, v equal to 120t plus 32. When I put t equal to 0, I'll get v as 32. Not happening. And E, v equal to 120t plus 32. So when I put t as 0, I get v as 120. So B and E are happening. So I need to use one more value to check which of B and V is true. Let's try B. So I'll plug in t equal to 1. So I'll get v is equal to 32 into 1 plus 120 for B. And for E, I'll get v is equal to 120 into 1 plus 120. I've plugged in t equal to 1 in both the expressions for B and V. This works out to 152. This works out to 240. But what should V be when t is 1? Here we have it. V should be 152. So B gives me the right answer. The answer is B. The linear relationship between t and V is 32t plus 120. A neighborhood recreation program serves a total of 280 children who are either 11 years old or 12 years old. So we have some number of 11-year-olds and some number of 12-year-olds. So let's denote the 11-year-olds by X and the 12-year-olds by Y. What's the first thing we know? That there are a total of 280 children. That means X plus Y is 280. That's the relationship between the total number of kids and the kids who are 11 years old and the kids who are 12 years old. The sum of the children's ages is 3238. So what is this information? There are X 11-year-olds. What is the sum of the ages of all the 11 years olds? Well, each is 11 years and there are X of them. So 11X. I'm adding 11 X times. Similarly, what's the sum of the ages of the 12-year-olds? Well, they're Y 12-year-olds. Each is 12 years old. So I add 12 Y times to get 12Y. So what's the sum of the ages of all the kids? It's 11X plus 12Y, and that's given to be 3238. And these are my two equations. Solve them and find the value of X. They want the value of 11-year-old children. Another way to do it, don't solve, plug in. Take X equal to 55. So this is 55. Find Y from this equation. Use that value of X and Y here and see if you get 3238. If not, try the next value. Try 122 for X. Find out Y from the first equation. Plug in that value of X and Y in the second equation. See if you get 3238. When you get 3238, you have found the right values of X and Y. So there are two ways to solve this. Choose the one you prefer. The average of 5 numbers is 12. When one of the numbers is discarded, the average of the remaining numbers is 11. What is the discarded number? So what does it mean the average of 5 numbers is 12? How do I find the average of 5 numbers? Well, I find the average by adding the 5 numbers and dividing by 5. So I total 5 numbers. I divide them by 5 and I get 12. That's the meaning of average. So from this equation, what can I find? I can find the total of the 5 numbers. Total of 5 numbers must be 12 times 5 equal to 60. Note that I do not know any of the numbers. I just know that their total is 60. When one of the numbers is discarded, the average of the remaining numbers is 11. So now they've given me the average of 4 numbers because 1 is removed. So total of 4 numbers divided by 4 is 11. Similarly, I have those 4 numbers. Their total divided by 4 is equal to their average, and the average is given as 11. So the total of those 4 numbers is 11 times 4 equal to 44. So what two pieces of information do I have? I have the total of all 5 numbers and I have the total of 4 numbers after one of them was removed. And what are they asking? What is the discarded number? So if I have the total of 5 and I have the total of 4, their difference must be the 5th number. So 5th number must be 60 minus 44. It's the total of 4 and the total of 5 and their difference, which is 16. So I know that the discarded number must be 16. Answer is E. So very interesting way of doing this question. I do not know the other numbers and there's no way I can know the other numbers. I only know the total of 5 numbers and I know the total of 4 numbers. So I know the 5th number is their difference. So we have seen some examples of word problems in this lesson. And there are plenty more examples in various topics, but we've already covered them in those topics. So let me just list them. Ratios and proportions, speed, distance and time, percents, simple and compound interest, profit and loss, rate and work, and mixtures. All these lessons are in the video lessons on arithmetic, and all of them have word problems to do with those topics. So please take a look at them again if you have some doubts on word problems.